Okay, I think we are ready. Yeah, great. I have all the systems enabled and 5 different channels set up. How is that sound? It's actually a bit ringy from here. Okay. Um, okay, and people on the remote stream are hearing and seeing, I hope. Alana can check. Is the remote stream happy? Yeah. Okay, welcome back for day 2. I hope everybody slept as much as I did, or more, hopefully. I was up polishing these slides until about midnight. Yes, we have pretty much the same format today as we had yesterday. Morning of presentations and afternoon of workshop and lab time. Is that sound okay? It's ringing a bit. Yeah. And okay, I will speak softly and clearly. I also should have given it out yesterday, but a couple of laptop stickers. If you want to decorate your laptops with Earth Engine goodness, there's some Earth ones and some Earth Engine ones and some Earth ones, slightly different logo. There's probably about 50 of each, so 1 each is the rule, and we'll see if there's left over after that. All right, let's get going. First section is talking about widgets and apps. So all the examples I showed yesterday were developer working alone kind of examples. You want to build your map, get your data table. The second half of the story very often is sharing your results, getting it out to a collaborator, getting it out as a press release, or sharing it with your thesis committee, or any other interested or not so interested party can view your work too. It's also whoops.
Sorry.
Also, thank you. It's very useful to start building interactive applications for your own, internal purposes. Just working by yourself. If you are wanting to visualize alternatives or iterate quickly on an algorithm by setting parameters, or more than just zoom into the map, set up alternate views of your data and step through layers of time or other parameters on your map more quickly than you can do. You can always do this by editing the code and hitting run again, and editing a bit more and hitting run again, but often you want your testing cycle to be as quick as possible. So you can build little interactive apps in the code editor and explore your alternatives as fast as the page will load. When you are publishing apps to non-experts, you often go into a storytelling mode. I'm hearing this word storytelling more and more in this community, in fact. People like stories. People like you to lead them through the data and present things in a logical order and present it in a way that people can relate to. And building an app can let you start telling, mini stories perhaps, but useful stories around your work. I'll start by stepping through a few example apps that people in this room even have built. I'm looking at you, Madhu, and maybe others, in fact. So, yes, indeed. This is an app that Madhu built last year to visualize the floods in Kerala in India. It's using Sentinel-1 radar data to identify flooded zones, and the intention is so that community decision makers can see, zoom into the map, assess areas in their district. It's published as a little app with map on the right and instruction and a little bit of interactivity on the left. But this is as complex as an app often needs to be. Is just, here's my data, here's the explanation, here are a few things you can do to adjust and zoom into it. And if you are exposing tools for decision makers, you don't want to give them an infinite number of choices. You want to say, well, I need to specify my district and that's about it. I'm sorry, the sound is really ringing and annoying me. Is it okay for everybody? Okay. I will ignore it then. Is it that?
It's definitely this one.
Okay.
So this one's much louder because you can hear me.
Okay, that
Maybe
is a bit better.
Yeah.
Yeah. Okay, that's there.
Well, that's both of them.
Oh,
Okay, that's both. That's awful.
Yeah,
Okay.
yeah.
No, with that one moved away, that was pretty good.
Yeah.
Okay. Yeah. Thank you. So you can provide tools for decision makers, or this was a one in the Netherlands which was published as a 2-page open spread press story analyzing drought, and the interactivity in this case was a simple left-right slider. Left-hand side is pre-drought, and right-hand side is very much yellower post-drought. Again, a little bit of interactivity. Again, you can click on individual regions and get statistics for that region. And this audience can all read the Dutch too, can't you? Or it might not be a public release at all. It might be, hey, I've published a rich data set. In this case, one of our users, Gennady in the Netherlands again, has been doing a lot of hydrology work and done water surface body identification and river flow work and other things too. He's built this global app of, water bodies and tracking the evolution over time of those water bodies as well. The intention here is to show off your data set, saying, hey, there are useful high-resolution data here. You don't need to write your own tools to explore it. You can see a lot just from the app. This is an app built by Sander Venter from Cape Town, who's, I think he's off in Norway now. It's a bit of a hack, but it's a kind of a cool hack. What he's done is, I'm sorry. It's in the storytelling mode. He's identified a bunch of points around South Africa, and this is part of a larger project called Rephoto, where you go to a place where a historical landscape photo was taken about 100 years ago, and with a bit of talent you can find exactly the spot where the photographer stood before, and get the same perspective again. And using the slider again, you can see how much the, in this case, woody plants have grown up in the same area in those 100 years, with the attendant effects on farming and livestock in particular. The reason why I say this app is a hack is because we don't have a photo viewer in Earth Engine. So this is a geotiff. He's actually converted the photo to a map, and it's at 00 lat long, and displayed it using the map viewer. And you can't tell. It works beautifully. And he's managed to hide all the map controls, and it's nicely done. And now we don't need to write our own photo viewer because he's established a technique actually. Again, presenting data sets. That this is again Sentinel-1 radar data, which is a tricky data source to get intuition about. So this just lets you set various bands and parameters and visualization colors for mapping to the Sentinel bands, so that you can see two different comparisons, this time over the Nile Delta, to show off that data set. This is really another data set show-off example, showing vector data, time series, the route on the map, let you build a comparison. You can see that you might well have just built this thing in your code editor for your own use if you have all these data layers that you are working with, but it is a click or two to get this in public form for everybody else to view it as well. And sometimes, last example, this is from the United States Forest Service, managing and analyzing forest fires in the Pacific coast of the US, which has been hit by pretty major fires, tens of billions of dollars of damage in the last year, to the extent that the power company is going out of business because they were held responsible for sparks from the power line. So pretty serious issue in the entire US West Coast. But from the Forest Service point of view, they have an internal tool to share with other departments and people on the ground at the Forest Service to show the burned area. And this particular one does not have a trend analysis in yet. Okay, we should do that. And lets you work with your collaborators or your clients. There are also, and this is a great starting point for your own apps, if you go to the Google Earth Engine app page, we have a small gallery of example apps. Let's pick on one. Let me show you. Okay, this is probably about half our apps work in this split panel mode. It is just a handy way of providing a bit of exploration capability, picking two images, radar band images, and as it loads, I will speak more slowly. You can see how the upward and downward polarizations look quite different around that river course there. Not so different over the hillsides. And with this split map, panning works. You can pick separate images. The application is pretty much that. The thing to note is, besides the things that the lawyers made us put there, there's a link to viewing the source code of the app. For these Google Public apps, we've added this link, and when this loads, you get the same source. You can run the same app again in the code editor, and in keeping with the healthy philosophy of stealing code, you are most welcome to use this as a starting point for other apps. I'll go over the details of how to write the app now, in fact. So before we can just press the button to make an interactive app, we need to add some facilities to the code editor, to the JavaScript libraries, to actually build interactive widgets. So at the bottom half of the screen here, I've just shown a few widgets. Like you could do simple things, just put little info panels on the map. You can build interactive things like a date slider, pick a year, all useful components. Other input things like a checkbox or a text box or a selector, drop-down selector kind of thing, so that users can provide input. And then things like charts and labels and maps and thumbnail images can all be put on the map display area directly. You will notice I have map here. You can put a map on the map, and in fact, both ways. You can get rid of the map and just put panels and information, and you won't get a GIS style app at all. You'll just get a regular web app really. Or you can add multiple maps and use it for comparison purposes or whatever. So here are some more examples of the kind of selector objects, buttons, and charts you can put on the app. Each of these objects emits events. When we talked yesterday about the ways we could use functions, and functions can work in this callback mode where this function will run when some other event happens. This is one of those other events. So when someone clicks a button, you can run a function, and that function might add a layer to the map or perform a calculation and tell you, give you a time series at the current point or anything like that. Let's show what that looks like in code. when it loads. Gonna get that one out the way. Let's do a simple example here. Yes, if you click on this link or type this link into your browser, you can get to this repository as well. So, well, let's run it and then explain. So, in this case, the first thing I've done, the statement at the top, UI root clear, says I don't want the map anymore. I want to start with a blank screen. Then I'm defining an object which is a button with this new function, UI button, which has just a label that creates that button. By itself, it doesn't add it to the map. If I wanted to add it to the map, I have to do a UI root add call. I'll put it at the bottom here. The second thing we've done with this button and this code, and you find often with this interactive code, the order in which you write things is, flexible. It's difficult to come up with a single logical order, and there's a little bit of up and down you will need to do when reading the code. So reading kind of from the bottom up, we've added the button to the map. We then say, well, when someone clicks on the button, do something. What do? We add label. The label creates a second object called, in this case, UI label, which will also get then added to UI root in the same way. And one last thing is a print statement. Something's going to appear here saying how many widgets. This will be an array of widgets. How long is that array of widgets? We'll put a count over here. So, yes, those two things happened. Hello world got added as an extra label. If I click it again, it will get added again, and this is not a particularly valuable functional app, but it shows you the kind of things you can do. The print statement kept a log of what I was doing too, and showed me how many widgets were now in the root. So a total of 5 hellos and 1 click me are in the root right now. A lot of new concepts coming fairly quickly there. Are there any questions at this point? Half a question.
You'll probably get there, but I was wondering about how it does the layout.
Yeah. So you can see it at the moment, for example, it's every time I add a widget, it's going off to the right. Yeah. So the default layout engine and layouts are an important part of the visual design of your app. It defaults to reading order left to right. You can say, instead of going left to right, go top to bottom, and those are the two most obvious choices. You can also start doing things like, you've got this panel. In fact, this white area that the map goes in is called a panel. You can put panels inside panels and get nice kind of nested boxes kind of model, and you can have boxes going left to right, and inside that box you have boxes going top to bottom, and get a fair bit of flexibility that way. Each of these widgets, the panels in particular, has a hard-coded width and height set up, so you can set up panels half the size of other panels and lay them out as you would need to. Okay, so yes, okay, we demonstrated button on click, but most of these have an on change event when the user does something else with your app. The chart has also got an on click event, so you can notice that they clicked on 1992 in the time series, and you can set the map to 1992 data or something like that. Okay, this is an interesting extra bit of coding technique which I didn't explain yesterday, but I talked yesterday about these rendering functions, and I talked particularly about print and map add layer. You can build up Earth Engine computations, and it's not going to do anything until you actually print it in the console or add the layer to the map. Now, what if we wanted to do something more fancy than a print? I've computed a mean value from somewhere. that mean value is this latent computation until we actually trigger it with a print. But what if we wanted to show it somewhere else? And like most things in Earth Engine, the answer is you use a function. And the function in this case is what I'm calling a display function. So I've set out a few things first. I've added a label which is blank to the map, and then the function itself is display result. Will take an actual result value and call a set value, which changes the label that's currently displayed to whatever value you've just given it. So this is the display result function, and then the second step is this magic call called evaluate. So if you once you have this mean computation thing, you can say evaluate that computation, and the function which you give it will then be the actual display part of the literal value which has been computed. So evaluate is effectively converting that computation to the value that results from the computation. Let's look at an example which does that kind of thing. Easier to read through the code right now. So this is a slightly more complex example, but okay. First step, useful principle again. Read through the code from the bottom up. See what actually gets set up on the map. We've added an elevation layer. We've centered the map. We've added a thing called an inspector. What's an inspector? Inspector is over here at the top. Added a panel full of widgets to the map, and then we set up an on-click event. I think I have this example, here in the code editor too, just to work with it. I think it's this one. Okay, this is a slightly more complex example. It's got NDVI as well. But the idea is when you click on the map, it will display that long and not a panel. Okay, not exactly the same example, but that gives the principle. But I'll take this one. It's good enough to work through as a demo. Once I've written that, 2 labels in the panel, NDVI on the map. Let's say, and this is a view of Tokyo. Let's say we've built this app. We're happy with the content of our data set. We want to share it with the world. The magic button is this one over here, which is meant to look like a little gallery of apps, much like the icon you have on your phone, actually, some phones. I reset this account before the presentation, so I have no apps to display right now. You click New App, and okay, we can call it something exciting like Demo, and it auto-assigns an app ID based on the name you've given it, but this is going to be the thing that appears in the URL. When people want to view your app, you'll go to this URL. You can see my very short username there, and that app ID. There's one extra bit of administration work. I said a click or two. This is the or two. The administration work is to identify to the Google servers which app this is coming from, and you want a encrypted token which does that. The token is called an API key. I'll just walk through the flow here. It's a click. There's a lot of explanation here, but you can really just click the Create API Key button, and it asks you to. I'm going to pick up. I'll do create a new project actually. You create what's called a Google Cloud project. If you haven't worked with Google Cloud, you don't need to know much, except that it has this notion of projects. in it. Projects are Google Cloud's way of managing computation and storage. You can, just like with Google Drive, Google Cloud has an analogous storage bucket system where if you work with Earth Engine export to cloud buckets or wanting to store large volumes of data in the cloud without downloading it to your workstation, cloud buckets are a logical choice. You also have things like Google Cloud virtual machines, so you can run R from a Docker image or set up the virtual machine to do whatever you want on the cloud. Very much like Amazon Web Services or Microsoft Azure or the other cloud offerings. It's pretty much a general purpose machine, virtual machine that you can do what you want with in the cloud. We're using Google Cloud just in a very small way here to identify a particular developer, you, the person who created the app. And the API key that we're creating will be tied to a cloud project, and through that cloud project, we will know to blame you if the app is getting a lot of traffic and we need to regulate traffic a bit. Most of the time, though, we've had very few incidences of apps, overloading our servers or anything like that. We put this mechanism in place so that, as apps take off and, no one's hit the front page of the New York Times yet, but there are situations where we have to actually think about protecting the Earth Engine servers as apps get terrifically popular. And the API key is the identification mechanism so that we know where all the traffic is coming from. When I create the key, it gives me this security token, and it gives me a chance to take a drink. It takes less than a minute, I hope. Yeah, that's the token. I can copy that and drop it back in here. One last thing I can do, if I choose to, is I can put up a description of the app. I'll show you the gallery in a moment. You hit publish, and now there's a list of all my apps. I can go to the demo, and you can see that's the URL that was in the published dialog, and there is exactly that little bit of interactivity, that long, as I said in the code editor. The gallery is a page that looks very much like the Google App Gallery I showed before. I didn't have an appropriate image, but these are my featured apps. I can show them in a table form as well, which puts the descriptions there as well. Lets people click through to the app in the same way. And this is the URL that we've created for all Earth Engine users. So dg.users in this case, but it'll be whatever your Earth Engine home folder name is in the URL there. Anybody, it's public, anybody that goes to this page will be able to view all the apps which you've decided to add to your gallery. Quite often you don't want to put every single app in your gallery. You've got a number of works in progress, but you can decide to add to gallery later. And at any point I can go to the link here and change the name, add a picture to the gallery or anything like that. I do want to note that all these apps are public. You have to, they will be visible to the whole world. People can look in the browser and read your code as well if you are concerned, or your organization has concerns about sharing your code. Don't use public apps yet. You also have to, when you publish them, it mentions here, the app, if it's reading images or assets which you own, those assets must also be public. Otherwise, when people run the app, they won't be able to see those assets. However, nothing I can demo yet, but this is, No one has asked yet, but whenever I give this presentation, people ask, well, what if I don't want it public? What if I want to just limit it to my organization or research group or something? And yes, real soon now is the answer. The change is actually pretty small. There'll be one extra field in this dialog which says, give me a Google group full of email addresses of people you want to be able to see the app, and then you publish it as before. And slight difference when people are viewing the app, they will, if they haven't signed in already, they will have to say, well, what account am I using here? And if that account is, allowed on the app, then they can go through and use the app. Does that make sense? How's that?
If you have your own URL,
Yeah.
can you map the app's URL that you get by default to like your own custom URL?
Yes, you can set up, depending on your domain providers and stuff, you can set up a domain redirect like that. One thing we've done with a lot of apps as well is, for example, is this a URL? This Intertitle Explorer, which I was talking about a bit yesterday, it's often very handy to build a Google Sites page, which has more context and links and explanation, and you can do an embed of the app in the Sites page, and that's link your paper from the Sites page or any other supplemental material, and the app works full screen or directly in that Sites page. Yes. How do you search for them right now? Google search will find them, and like searching for any other web page. In fact, if there are links that Google can follow which end up at the app, you've published it on your departmental homepage or wherever you like, Google search will find that. Will look at keywords and search in the same way. Okay, if I try to do a demonstration right now, it's not going to work, I know it, but it's searchable like any other web page. Yes.
Can you load legacy services into the app? Like if you have a WMS server with some contextual layer that you want as a background or something like that?
Yeah. So, can you load layers from other services into the map or into the app? Yes, if you export that layer in a format that Earth Engine can read. There's a standard kind of pyramided tile storage format, which Google Maps can read, and Leaflet and other plugins can read as well. I'm imagining that you've got tooling to write to this tile format.
But you have to upload the data to that engine. You can't have the layer pulling from your server constantly as you use this app.
Yeah, yes, you can actually leave the data on your server.
Okay.
It's most commonly it's a set of JPEG images or PNG images set up in a standard kind of file format. It's a directory in a cloud bucket or something like that. But you can point the app, or in fact, an Earth Engine script, at a layer which gets stored elsewhere. This is something that I did not cover in the slides, but where is a window I can use? Do we have an example here? Okay, we don't have an example here, but I'll show you in the docs. There's an object called a cloud storage layer, and once you've exported your data to a cloud bucket, you can say, hey, use the data in this bucket and display it as a layer for comparison purposes, with all the rest of the Earth Engine layers in the map. If you haven't heard of this before, it's because we released it 2 weeks ago. Look for the post in the developers list pretty recently. Good question. Timing, well timed. All right. That is a wrap for apps. I've talked about the publishing flow. I've talked about private apps up and coming. the best thing to do again is to steal code from the demo Google Apps, also from the examples repository here is pretty rich. Okay, displaying images and so on, but at the end of the examples there's a whole bunch of user interface interactivity, small scripts that you can use to base your apps on and adapt from there. Okay, all right, I'm going to take a quick break and then we'll get on to the next section on talking about time series and change detection. Okay, thank you.